Hi. So this talk is going to be in English, but feel free to throw in your questions in German or English. Doesn't matter to me. So I want to talk about IT security for web servers, game servers, and application servers. Now, first of all, this is basically what modern data leaks look like. Often, many companies are like, hey, we were hacked, but this is basically what really happened. Nothing was secured, and data was just publicly available and stuff. So, we got several recent examples. The city of Lübeck accidentally sold a hard disk that contained 33,000 emails, or Log4j is a bug that's still unpatched in many, many servers, even to this date. And CDU had a very leaky app that just didn't ask for any authentication. If you just asked, hey, give me that data, then they just handed it over. And with all that happening, the question is, how can we avoid this for us? So we want to protect our customer data, and this talk will be a bit technical, especially here in the later points. So first off, we're going to talk about trust and whom do we trust and how do we trust as an organization. Then data sparsity, which is basically like um, how do you basically limit the data that you can leak. Then request authentication is a bit of a technical part, limiting API discoverability as well. But standardizing processes, that's something that anyone can contribute to within the organization. And our goal is to avoid this. This is a way to have everything super secure, but we don't want to do that. We want to stay highly connected. And first of all, where did I get into contact with so much IT security stuff? Because I'm a developer, actually. So, first off, I had 3 years of experience working on a proof of concept MMORPG. Then I was working as a senior software engineer on content management systems, which included many very large corporations as customers. And they had some very interesting IT security problems. That's where so at the first position, I thought of systems, but never really saw them out in the wild. Here, I actually saw them out in the wild. And then my most recent occupation was 3 years as head of development for a company that developed medical applications, which is where things got really dirty, IT security wise. And now I'm founder and software architect in games. And my focus has always been backend development. But because nobody else wanted to do it, I've also always been doing DevOps and security ops. So basically, there's that beautiful joint term DevSecOps. And basically, to sum it all up, it was once my job to think as dark wizards do. So now we get into it. Trust, or basically why we don't trust. So first thing is, especially for game servers, we never ever trust the client. With every single request, we always validate the authenticated user. Like, okay, you say you are user A. Are you really user A? Um, and also, if that user says, hey, change the profile name of user A to some other name, then we have to ask, okay, you want to change this user's name. Is this your user ID? Is this the correct? So you are authenticated, but are you also the user that's the target of this operation? Then we have to validate the values, because if, for example, we take any game basically, and it's like, okay, you're sending me a signal that says you win. I better check and see if you really won, or else that's just a very easy way to create wall hacks and weird other funny cheats. Then our sources may be compromised. Our apps that are running may be compromised. It's very, very easy to decompile apps and modify them. Our servers may be compromised. So if you have a system that has 5 different servers, like maybe you have a login server, maybe you have a game server, and the game server should not just blindly trust the login server, and vice versa. Always have those servers question, okay, are you really the server you say you are? because else someone could create a nice little man-in-the-middle server. Then colleagues' accounts. Now, if I'm working in a company with 10 colleagues, let's say maybe someone from marketing has access to our database. We'll come over to that part again, how to limit the damage that would occur if this account were hacked. But yeah, always question if any account that's accessing your system is compromised. And also, social engineering is super effective. That's we'll get to this point later on. It's not just like people walking into the office and chatting someone up, or emails or phones. It can be a combination of everything. And lastly, don't even trust yourself. If you are developing a game that has a lot of customer data, get an external penetration test. The word may sound funny at first, but it's basically a professional IT security test. You hire a company to hack your servers and document everything and tell you where they found weak points. Very, very important. Now, talking about IT security, it's always important to wear many hats. You basically look at your own system and like, what if I wanted to do this? What if I wanted to attack that? Now, first of all, it's how can I find attack vectors? So these would be the different points of your server that you can attack, or of your organization that you can attack to get that delicious customer data. First of all, your APIs, so basically your interfaces of your servers. That's easy. Then GitHub repositories, of course, that's an easy one too. You might have a password in some file in GitHub. Easy to find. But then data visible during screen share. For example, I'm holding a presentation here. If I accidentally, like on the side, click something and open up a window, this might be a text editor that has some file open with passwords. Happens quite often, actually. Then screens visible in social media posts. My favorite Instagram posts are those where people are like posing like this in front of a screen. I'll zoom in on the screen. What do I see there? Okay. Well, I can already tell the organization is using Microsoft Teams. That's already some info if I want to attack that organization. And my favorite has to be contacting support and asking for information. Like just have some random email address. Hey, I'm user blah blah blah, and I cannot log in anymore. Can you please help me? Just ask nicely. Oftentimes you'll get stuff. Error messages of your apps. We'll come to this later on. So I don't want to spoil anything, but there's one very popular error message that many apps and games have that just completely give away information about users to anyone on the internet. And then after you're seeing like, okay, from where can I attack the organization? Now, which data could I get from outside? Admin passwords, easy. Customer data, also very obvious. Metrics, the amount of users registered and stuff. Now, that's some info. Some companies might not be too cautious about sharing these and not treat them as secretive as they should. But if the more I know about your system, the more I can abuse this information just to get somewhere. Then information about the server software. If I find out, oh, okay, you are using, I don't know, a Windows 7 as your server's operating system. The Windows 7 is not supported anymore. There are several bugs in Windows 7 that I can abuse that would be fixed in any other operating system, to be honest. And especially also apply this to internal roles. I'm not only talking about like, okay, people from marketing shouldn't have too many rights, too many permissions on the database or something. That's one thing, of course, you should always pay attention to. But my favorite has to be job applicants. I have so often applied to a job. I've been invited. I get a coding task as a programmer, and they give me a company laptop to work on this assignment. And my first question is, with which network is this laptop connected? To the actual company network? Is there maybe some Google account logged in so that I can participate in meetings with remote colleagues? Is this a full company Google account? So do I have access to Google Drive and stuff if I tried? Stuff like that. So job applicants can be very dangerous if people do not set that up correctly. Then data sparsity. How do we limit this is basically limiting the damage in case we do get hacked, because let's face it, there are many, many very good people out there, as in skill-wise good. If they want to get into your server, it's a matter of time. So you always should consider the possibility, what happens when we get hacked or if we have a security breach, because chances are very high that it will happen someday. And on that day, you just have to react accordingly and limit the damage. So basically, we're having a look at a clean desk for our data. So the more data we have, the more we can leak. So I personally, this is probably where a lot of marketeers and people like that would fight me on this, because they want as much data as they can have, and I want as little data as I can have. So for one of my tips is cloud providers like Google, Microsoft, Amazon, etc. They have large IT security teams. They have more people working on IT security than you have working on your game. And one of my favorite things to outsource is an authentication provider. There's OAuth as a standard. And oh yeah, by the way, I'll be dropping a lot of names here. I'll also upload the sheets for you, so you don't have to write any names or these shortcuts down all the time. I'll be sharing that info later. I always try to use managed services. That's like a managed database is something that I don't have to take care of. They install the updates. They take care of like routine work and stuff like that. They just keep the databases running. I only use it as a service. And it costs a little more, but in the end, I save so much money, even if I'm doing small stuff on it. Then one checkbox to always tick is use encryption at rest for all databases. Most databases have this feature out of the box. And encrypt whatever you do not need to know in the database. I'm talking about end-to-end encryption here. You don't have to use anything too fancy. Just before you even upload this information from the server, for example, what if you do not need, well, let's just say there's a name, like the player name of the real person behind it. You do not need to read this name. You want to know it so you can say, hello, Sven, if Sven logs in. It's not too much of a useful example, but you do not need this name in the backend. So we encrypt the name, then we upload it. So in our database, we only have some encrypted something. We can never, ever read this name. This is downloaded and decrypted then again on the customer's machine. So that's one information that they can always see, but no employee in my company can ever see this information. There might be some information from time to time that you do not need to see, but the player needs to have like a synchronized. Or technically irrelevant text entries is basically what I also call them. Also, limiting the amount of data leaked by a single breach is always valuable. For example, having different databases for different data types. It can always be handy. Only save what you need. I believe this is also a requirement of the GDPR. And we always want to limit users' access to data. This is especially true for administrators. Now we're getting to the request authentication. This is where our data is in the middle here, and we're building multiple walls, we're building a moat, etc., to make it harder and harder to get to our data. So basically, we're building a small onion of security around this, because no single solution will provide you perfect security. And also, all of these won't give you perfect security, but the more layers you have, the more secure your data is. So first of all, I always recommend adding a signature to your requests. There's, for example, HMAC, but there are also simpler systems. It basically takes the request that you have, like, for example, I'm sending, hey, I want to log in. It's probably going to have my user ID, a password hash, and stuff like that. And all this information will be taken, thrown through an algorithm, also together with the timestamp and the server IP address, maybe, or the server URL. And that will be turned into, will be basically hashed into a signature. That's going to be sent, and the server then has to validate the signature. The server then sends a response, also signed, and the client has to validate the signature. This makes it nearly impossible to catch requests, modify them, and then send them along their way. Very important, do not roll your own security systems. Whatever you program, it will always be less than what you can find online in the open source community. Then we always want to authenticate users. For example, OAuth has JWT. Nope, that's not possible. Sorry. Oh, there. Yeah, there's always JWT. That's a special token in your request headers, which you can use for authentication. And with this, you do not have to have user IDs in your request. So that means we'll take the request and just get the ID directly out of this authentication token to identify a user. Because many systems, I've seen this in expensive systems by very, very large multi-billion-dollar companies, where you have a request, they authenticate, but they send a user ID explicitly. You can alter the user ID, and then you're using the permissions of one user to change the password of an admin. Been there, done that. Also, we do not rely on HTTPS when I'm working on projects. We always use simple encryption for sensitive data. So we always use HTTPS, don't get me wrong, but we never rely on it. So we encrypt our stuff via HTTPS during transport, but we always assume, what if it breaks? Because we already had that happen once with Heartbleed, and it was a catastrophe for everyone, but not for the app that we were working on, because we already had our very sensitive data encrypted, so it wasn't too bad. Yeah. Also, certificate pinning can be very handy. This is a technique where you just say, hey, client, this is the only HTTPS certificate with which you can connect. And if your server has that certificate, then they can communicate. If your server does not have that certificate, then they cannot communicate. So you have to be very careful there that you do not lose your certificate, which is a thing that can actually happen if you're not too careful or not too familiar with certificates. But if you know your way around them, you should be using certificate pinning or have a good reason not to. Then also, I like to authenticate every single request. Like if the client sends 10 requests through the server will check the authentication 10 times. Because what if I send 5 requests, but the third one was caught by someone and forged? Like there's multiple ways where you could actually have that situation. And in some cases, then it's like, okay, yeah, the first 3 were valid requests, so we'll just accept the rest, and that can be very fatal. And last but not least, I recommend not caching until it's necessary. That's basically the principle of optimize later, because caching can introduce messy things also with security. So if you start caching, always have a security look on that. Like, does access to your cache also check all authentication mechanisms and stuff? So that can be very messy. And yeah, also cache invalidation is one of the hardest things to do on the face of this earth. So now, Here, another one will be limiting API discoverability. This is basically just providing as little information as possible to actors from outside. Here we see my very, very favorite error message on the internet. This is a forgot password form. I enter my password, click change or reset password, and then the web form tells me there is no user with this email address. Okay, that is very valuable information because now I will go online, get a huge list, for example, that very famous list that Adobe leaked with email addresses, like 10,000s, 100,000s of email addresses. Write a small script and have every email tested there. And my script will check the error message. Account not found. Okay, user is not registered. Password reset email has been sent. Okay, this user is registered there. Now, the last company I worked for was a medical application developer. So this was very critical information to know if someone is signed up there because it tells you, okay, this person probably has a diagnosis that is relevant to this application. So in that moment, this error form here would be leaking medical data about people. That's probably the best thing you can do. So yeah, error messages are information. Don't underestimate them. And one thing that I also recommend, now this can be a bit tricky. So in general, if you only limit your API discoverability, but do nothing of the aforementioned castle building that we discussed, your application is very unsafe. So this is just a little cherry on top of your ice cream. Just to make the secure system hard to find. But do not introduce security by obscurity as your sole measure. That just doesn't work. It's been tried very often in the past, and you will be mocked in hacker forums for that. But one thing that I like to do in production is for all error codes, like every 400 code, every 500 code, I always return a 404, not found. Because that means that if someone is poking around your server, like just trying to find out which endpoints are there, and where can I find something that I could attack, then they always get a 404 until they have everything correct with HMAC. Here with HMAC, it makes your API invisible to script kiddies and even some pen testers. One more recommendation could be for your pen testers, have them test with the 404 hack in here and also disable it and let them attack you, because else you're just relying on that invisibility cloak. And if someone just steps on your invisibility cloak, then you're standing in the middle of Hogwarts and yeah, everyone's seeing you. One thing to note here is that it not only makes debugging harder as a developer, like very, very hard. So you cannot debug your production server with this enabled. But it also makes it impossible to offer a public API. Like if your name is Twitter and you have a public API which people should be using, do not do this. Last but not least, one of the most important things, standardizing processes. Now, first of all, automation reduces human error. So automating as much as we can is a very, very good idea. Checklists and processes for non-technical roles also reduce errors. Do you have some process that some files are always uploaded? For example, image assets for the App Store or something. Have processes for this. Have a checklist for when you are deploying your builds for the PlayStation Store or something. Have checklists for working with people who are applying for jobs within your company. Have processes for anything basically defined that happens regularly, because then people can just go along these checklists And that reduces human errors, and thus you will leak less data in the worst case. One big thing is support communication. Have answers for frequent questions, and also like someone is writing you, hey, GDPR Article 15 and 17. I need a data. I need you to send me my data, and I need you to delete my data. How do you do that in a secure manner? If I write, hey, I'm Benjamin Justice, please give me my data and delete it, this company cannot just send me the data in a response email. They have to validate that I am the person that I claim to be. And this is something that you can catch here because your support team will likely not be highly technically trained. So they have to be trained in the processes. Social media communication. Which information do you share? Do you send everyone with every single request to your ticketing system or to your support email address, or do you answer some things in your Instagram DMs? How do you handle stuff like that? And yeah, simple checklists can just go such a long way for many things that you cannot automate. I also always recommend having an IT security guideline. This doesn't have to be some 20-page document or something. Just have a load of checklists. Just have a small header like Windows notebooks, and then have a bunch of checklists, like how to handle specific things. How to use work computers in general, like which applications may you install, which may you not install, which networks are you supposed to connect to, do you have any guidelines for VPN usage? That's just, each one of those is a small bullet point in there. Handling USB sticks. My tip, do not allow the use of USB sticks. They can be the worst hazard for Windows notebooks. Email security. You can have Outlook and Apple Mail in their default configuration. And if you use them without configuring anything, they automatically download all attachments to your computer, even those which are in spam. And in Windows automatically scans every file that is written to the system and like, hey, do you have meta information that I have to process? And the virus that was freshly downloaded is like, yeah, here's my metadata. Here, please execute this. Also in Apple Mail on Macs, this is also can lead to a security breach. Web browsing security. What do people have to pay attention to when using the internet in general? Fake download buttons, etc. Then physical access to the office. Having a policy that people always pay attention to the door, that it actually falls into the lock when they leave the office, is very important. I once worked somewhere for a very brief time. I left the office and noticed this door doesn't fall into the lock completely. It just like falls, closed, and almost closes. And one time I arrived at that office, I had forgotten my key card. I'm like, crap, I cannot go in there and get my computer. Lucky for me and unlucky for the office, I was just able to push the door open. It wasn't locked. So without my key, I was able to enter, grab my laptop, which was good for me. But in total, that was effectively a security breach by one of our own people, which was good. But that was in total not cool. So in summary, this is how you minimize your attack surface and avoid cutting through network cables and isolating yourself in the basement and just, I don't know, you have an MMORPG and just send out letters to people with what their character is doing or something. I don't know how that would work. First of all, trust no one. Always think like a dark wizard does. Second of all, data sparsity. Outsource your services and servers when possible to companies who have huge IT security budgets. Encrypt all your data that you do not need to see yourself, and be very sparse. If I do not need the user's name, I don't need it. For example, maybe all invoicing stuff is running over a different server and authentication is running through a different service, then I do not even need to know the email address, technically, to operate the server. Then request authentication. A multi-layer security is a good solution because if one of those layers fail, you always have other layers. So you're not left with nothing if something fails. Then limiting API discoverability, keep your error messages vague, but keep them helpful enough. Like nudge the user in the right direction, but do not tell them exactly what went wrong. Always ask your techies, like, does this give you information if you wanted to hack the server? And yeah, just 404 everyone if this is not a public API. That's just a last cherry on the multi-layer security. And last but not least, standardizing processes, even checklists will do. As I mentioned, this has been a lot of input here, and I will be uploading these sheets here so you can look up everything. And I hope that this helped some of you. And I'm also very eager to maybe hear about stuff that I have maybe mistaken here. Like in the last time I held this talk, I was corrected in 2 points, which was very, very useful for me. So if you have information here on this that can further improve security stuff, I'm always up for that. And yeah, here, of course, image credits, but yeah, I'm open for questions now. Thank you.
I was muted again. Wow. Thank you very much. I would try to go in English as well. Let's see how that goes. So thanks a lot for your talk. Very technical, but very, very important. So I got a few questions myself here. You said the first rule is never to trust the client. But what I ask myself is, if you have a software running that is very performance intensive, like a real-time game with physics calculations going on and so on, that seems not quite feasible to run that kind of game. Like, for example, Counter-Strike, where you have like, I don't know, 10 or 12 players and you have like thousands of games running and so on. Is that feasible at all?
It really depends on how your game is communicating there. You just mentioned a game like Counter-Strike. There are several different ways how the networking can be implemented there. In general, I would always suggest, or I myself also, if I were to now build, I don't know, Quake 3 online, then I would try to request every single authentication and question everything the client sends me. And only if I run into performance bottlenecks, which looking at games like Counter-Strike, you always have those individual servers which host, I don't know, like 30 players at once. I do believe that should be no issue. So computers nowadays are so ridiculously fast. We, in the last company that I worked with the medical applications, we partially had very, very small servers running and authenticating every single request. And every time a user wanted to update, they sent like 50 requests. And we had like 10, 20 clients updating at once without performance impact. So I would always just first try things out without optimizing it, because computers are so fast, I always underestimate them. And only if I notice that there's something fishy going on there, then I would still not trust the client, but I would then see if I could maybe optimize or maybe also introduce caching. For example, it's possible that you cache those authentication tokens so that you don't run over to the authentication server for every request, but just you remember, okay, I just checked this token, it was valid. So for the next 60 seconds, I will not check it again. I will just always see, is it exactly this token? Then it's okay. And after 1 minute, then you do the round trip again to the other server. Like that's how I would step by step tackle that.
So step-by-step system that gradually is more or less granular to tackle those issues as they come up.
Yeah, you have your onion basically, and
Yeah.
every layer can be optimized. So first thing would be, of course, to check which of those layers is taking the most time, or maybe it's the business logic taking the most time. Then you don't have to optimize anything with your IT security.
Yeah. So you mentioned you were working on a software product in the health sector. So what would you say? What are the greatest differences between IT security in the video game space and when working with medical data? Or is it just the importance of the data and the rest is quite the same?
So for one, it is the importance of the data, because if you leak a few email addresses of gamers, the uh, the PR storm that you'll get is not that large as if you were to leak medical information on 1,000 patients. Then you're done for, I'd say, as a medical company. Um, but the biggest difference that I noticed is that in medical, you have to get certified before you may enter the market. And that's not just for Germany, that's like for US and most countries I've read about. You always need certification before you may enter the market. So you have to go through IT security audits and checklists and stuff. So you are forced to implement at least some of these layers. And for games, the dangerous part actually is nobody will check your MMORPG server before you set it live. Or also you're having some live ops games. That's a very common example nowadays. Like you're building the next Candy Crush and you want to send all those analytics and have everything connected so you can have special events running and stuff. Nobody will check your IT security. So it's much easier to just trip and fall on your nose there.
Yeah. All right. So are there differences when protecting personal data compared to other data, especially when talking about data sparsity or the way or intensity you protect them with?
In general, I would always try to protect the personal data first and foremost. And in the end, if I have all these systems and they do not have any performance impact, then I will just apply them to the non-critical data as well. Because especially when talking securing your APIs and stuff like that, um, if it doesn't make a price difference, I would just apply the stuff that I've concepated for the personal data. I would apply it to everything. Also, like non-critical analytics, which only give technical information and stuff. One thing that I would note is that sometimes you have stuff like a web application firewall, which can be very expensive. If you have such an expensive component, then I would maybe say, okay, the critical stuff only runs through that web application firewall and the non-critical stuff doesn't.
Okay, all right. So in one example you gave, you talked about encrypting data that is stored in the database. So encrypting it on the client side before you send it to the server and store it in an encrypted way. But that means there has to be a static key with the client to decrypt if the data is retrieved. So how do I protect these static keys on my device or on the device of a user, especially if those are devices in companies or other locations where multiple users might have access to those devices?
Okay, so if you're talking about a larger solution where multiple users have different keys and stuff, then I would probably go and look online if there's a sort of authentication or encryption management service that can be used that's lying with the third party. Um, a cheap solution would be to have all clients share the same encryption key, because this encryption is only there for if someone hacks the database or if your own admins access the database, that they do not see the information. It depends on the criticality. Um, yeah, so if it's for a large scale solution, I would probably start Googling for a solution to manage encryption keys, because for very critical data, you always want to have this option of like this like please break the glass in case of fire. You want to have that possibility for very critical data, and that needs a more sophisticated solution. So one thing that we also did in one solution was we had very critical data that we did not need at all. And it wasn't too bad if the users lost it. We just kept the data on the device. We never sent it to the server. Like if they were to replace their device and did not have a backup, they lost the data. But it was impossible for us to leak this sensitive data.
Yeah. So if I heard you right, you already mentioned that there might be cases where you want to access the data. So, for example, I don't know, you get legal requests, or maybe from the police investigating, or whatever it might be. So,
or medical request. Yes.
Medical requests, and the user cannot access cannot access their account directly. The doctor has to, or whatever. So, how do you handle that? That you say, okay, on one hand, the database is encrypted. No one in the company should be able to see it. That's the whole point behind it. But we also need a backdoor. Doesn't that, I don't know, break the purpose?
Such systems, there you would probably have like your chief information security officer and one or two other people. They would have a system where they each need their security key, and all three or all two of these people need to enter their password basically to receive the decryption key, and then they can decrypt this data. So the systems that exist there, they are prepared for such cases where no single employee can just act and decrypt data. So it's really for these emergencies.
So it's sharing responsibility and getting security through that. Okay.
Yeah, those systems are super expensive.
Yeah. All right.
Probably nothing for games.
So how do you handle interfaces to other platforms like Steam, or I don't know, Google Play Games, or whatever other services you integrate? You have to use their methods, you have to use their APIs that might not be suffice to your security standards. Is that a problem, or?
It hasn't been a problem for me to date. I always treat, for example, Steam, I always treat it as a completely separate platform. So that's only for this whole social aspect. So if they're sending, hey, achievement unlocked, and I also need this information in my backend, I'll just completely have that split. And my social adapter will say, hey, Steam or Google Play or App Store, here, this achievement was unlocked. And directly after that, or in the same call, it'll go, hey, my server's achievement was unlocked. And there I can send other metadata.
But you also have some of those services that provide multiplayer capabilities for apps, for example, Google, and I think Apple as well have their services in the way that you can use them for real-time multiplayer, for example.
I haven't tried that yet, and as far as I know, that's always peer-to-peer, and peer-to-peer is inherently insecure. Not that it's bad for like small games, like small session games, like I don't know, Don't Starve, Valheim, games like that. When you only have like one session where you play with friends, you can use peer-to-peer there. But as soon as you have some competitive component or something in that, or if it's supposed to be MMO, then I would always not necessarily roll my own, but I would use other solutions, like, for example, Azure PlayFab has the possibility of hosting your own servers with your own code and your own IT security there, but at the same time having it speak with their APIs for live ops. And I think Proton, for example, also has a similar solution where you can roll your own code, but at the same time use their infrastructure.
Yeah. All right. So you talked about a lot of things that are quite technical and might seem overwhelming, and also, I don't know, quite expensive. Not money-wise, but maybe time-wise, or somebody has to do it. Somebody has to work into it. if you would give indie developers an advice, what would be the easiest, most feasible steps that you could take to make your, for example, online game more secure?
Yeah, so for a short version, I would definitely go through standardizing the processes. That's a very easy way. And here, oh, right, I'm not showing my sheets anymore in the presentation, but then I'll just do it vocally. So the signatures with HMAC, they are super effective. They are a bit of a hassle to implement at first, but there are libraries for it. You just have to invest that time once, and then it's really effective. And authenticating users can be tricky, but that's where I then use like any other authentication provider. It could be Azure AD B2C, or it could be Okta, or Auth0, or one of those big ones. Firebase, for example, is an authentication provider. Just use any of those, or Apple has an authentication provider as well. Use any of those, so you don't have to take care of that in the back end. And using that for authentication will already be very good. So that and HMAC, those are the two main things that give the most juice IT security wise.
Okay, cool. So I think that were all questions. Thanks a lot again for your insights. I hope that many people will also watch this video later to make their games and services more secure. And yeah, thanks very much.
Thank you too.